we're starting here with chapter 9, the musculoskeletal system. This will be the only chapter in this exam, so that should be good, considering there is still a lot to it. I believe you've got 50 multiple choice and then 25 labeling. It may be 45, because I think I've seen some that I'm going to take out, so depending. Do know the characteristics of the 3 different muscle types, and that's really all I want you to know on these. So cardiac muscle and smooth muscle, know that both of those are involuntary. We don't have to tell our stomach to churn and turn your lunch into chyme. We don't have to think about our heart beating. We don't have to think about taking in a breath. That's smooth muscle. So do know that both of those are involuntary, where skeletal is voluntary. Know that cardiac and skeletal under a microscope kind of look alike. So they look striated. Skeletal muscle, when we look at it in a minute, you'll know why it looks striated. There's some things going on with that muscle cell that makes it striated looking. Cardiac muscle, they have what are called intercalated discs, and that just increases the impulse across that muscle. Smooth muscle looks smooth. Okay, so a muscle is made up of a lot of things. It's not just one unit. So a muscle fiber is the same thing as a cell. So when you think of a liver cell, that's one cell. Muscle fiber is a muscle cell. Same thing, know it interchangeably. So you'll see inside of a muscle cell you have what are called myofibrils. So just step out. Each one of these are tiny, and we put them in a bundle like you would do, say, spaghetti. If you put a bunch of them and then wrap it, that would be all the spaghetti by itself is a myofibril. But one thing is a muscle cell. So muscle cell, then we'll take a bunch of muscle cells, group them together. Well, let me back up. Your myofibrils are then grouped together and encased in what's called your endomyosum. Like with cardiac, when we did cardiac, we did endocardium. We said inside that layer because it had 3 layers: endocardium, myocardium, and an epicardium. So the inside was nice and smooth, and it was endo with an E, not an I, but it was inside. Myo, the muscle layer, and then epi on top. So just like that, we have several different layers to a muscle. So myofibrils grouped together to make one muscle cell, which is a muscle fiber. We wrap that muscle cell in what's called an endomyosum. So endo, inside, the very inside layer of a muscle. Myosum, if you think muscle. Then we take a bunch of those muscle cells, bundle those up as well, and we end up with a fossicule. So this one whole unit here is a fossicule, and we wrap it with a perimyosum. We had periosteum, that was another one in bones. And it was the very outside layer. Huh?
You had pericardium?
We had pericardium. So think about taking all those cells and just wrapping them in a pair or a bundle, and we'll call it perimysium. So lastly, we take all those fossicles that are made up of muscle cells, that are made up of myofibrils. We'll take all those fossicles and put those all together to finally make a muscle. So this may be, say, a bicep or a deltoid muscle. One muscle made up of a bunch of fossicles. Wrap it with your epimyosum, like your epicardium, the very top layer, very outside. Not going any further. Fascia. So this white here, it's will start out. So your epimyosum will then come into what's called a fascia, and it's connective tissue, really strong connective tissue, your fascia. And it has to be strong because then it's going to grow into what's called a tendon. So that's what we connect muscle to bone, is by a tendon. Muscle is connected to bone via a tendon. Tendons are really strong. I mean, it takes a lot of force to break a tendon. A lot of times your tendons won't break, the bone will break. That's how strong they are. Now you can have a muscle connected to a muscle. So make sure you figure out it's not always just tendons. What's that called? Porneurosium? It's in here. Let's look.
No muscles attached to the bone of the body.
Looks like it is on 132.
Hey, Miss Lee.
Aponeurosis. So where you're attaching muscle to muscle, then bone. Yes, Jason.
What happens when you get a Charlie horse or something like that?
We talk about way ahead.
Okay.
Okay. So this here, muscle fiber, we're looking at a single muscle cell. Yes, it's made up of a bunch of or myofibrils, but this whole thing together is one cell. Just like when we made our animal cell out of the clay, that's one cell. It's got a bunch of stuff in it, organelles. Well, this is how a muscle cell looks. It's a lot different looking. There are some parts in here that are similar to our animal cell though. So, and of course they have totally different names because we got to know where it's at. So, the very outside layer when we made our animal cell was called what? Go back to that first chapter 2, the outside layer. What was that called? Cell wall or cell membrane. Cell membrane. So there, the cell membrane for a muscle cell has a brand new name. It's still a cell membrane, but it's got a brand new name, and it's your sarcolemma. It's got a brand new name because you got to know where you're talking about. If I say a sarcolemma, then you know we're talking about a muscle cell membrane. And when we start talking about contractions, twitches, and cramps, this is the stuff we'll be talking about. Go inside the cell, and you have what's called a sarcoplasmic, or let me back up. Cell membrane, and then you have a sarcoplasm. That is just like cytoplasm of our animal cell, the water part. We have that as well in this. So your sarcoplasm. You also have, go further in, and on top of these myofibrils, you have sarcoplasmic reticulum. Sarcoplasmic reticulum is the same thing as your smooth ER in your animal cell. Does different things. This is, so just like your smooth ER or your smooth endoplasmic reticulum, we call it now your sarcoplasmic reticulum. Remember, in the animal cell, it made protein and lipids. And it was smooth, no protein, lipids. It made lipids and transported lipids because it was smooth and slippery like butter, like fat. This smooth ER, sarcoplasmic reticulum, doesn't make protein either because that was our rough ER. This one, it holds calcium. When we start talking about muscle contractions here in a little bit, calcium is going to be very important. Your transverse tubules, don't worry about them so much. They're just to transmit the impulse deep inside this muscle cell. Mitochondria is extremely important for your muscles because what does mitochondria make? It makes energy. And what type of energy in particular? ATP. Adenosine triphosphate. It makes ATP. We've got to have ATP for what? We said energy. So what type of energy is the muscle doing? It's contracting. We got to have ATP to contract. In a minute, we'll look at how that actually works. So, when you build muscle, do you actually build muscle? Do we add more fibrils, myofibrils in here? People think you do because when you say build muscle, you think muscle tissue. That you build it, you don't. What's actually getting bigger and making this muscle swollen, is we start making more of mitochondria. Because we need, if we're using that muscle a lot and building muscle, we need more ATP. We're doing lots of contractions with it every single day. You need more ATP, so we start making more of these guys. And it makes that muscle get bigger.
So
hypertrophy is what it's called,
What
when
about,
muscles
like-
get bigger.
what about like drinking protein shakes and all that?
Protein shakes,
Yeah, 'cause I do that.
Because a lot of the things that we're doing and repairing, you're breaking down muscle, building back up, you have to have protein. Protein is vital. A lot of things that we make, you have to have protein to do it. So it's not only just the energy, and that's where creatine, when you take it, you'll see in a minute why it's so important, because it helps to make ATP. And that's why people take it.
Why does the pre-workout, why does that get you so energetic?
It's got a lot of caffeine in it, carbs and caffeine. Okay, myofibril. So we can take out one little myofibril, and inside it has myofilaments. And these myofilaments are called thick and thin. We're going to look at those because those are actually what makes the whole muscle, this whole muscle cell contract, is your thin and thick filaments. And those proteins are your actin and myosin. So without protein, those actin and myosin, if they get damaged when we're working out and we're overusing them, we can't repair them and fix them. So that's why you have to have protein. And that's why it's important to do protein 30 minutes after a workout. You want to hurry up and start getting it so we have plenty to start rebuilding those filaments again. Because they are protein. They're made of protein. A single muscle cell is called what? It's a fiber. Myofilaments all bundled together to make one muscle cell. Myofilaments are the ones that are actin and myosin together.
So the answer is what?
B. You have myofilaments, which are the contracting. So here, these are myofilaments. You have actin, myosin, so thick and. So actin, I think of A and atrophy, so that's small. I don't know how you want to remember it, but A for something. So it's the small one. I think of atrophy, so small. Myo, I think of muscle. It's big, so that's your myosin. Thin and thick. You put those together, you get a myofibril. You put all those myofibrils, you get one muscle fiber. I know it's a lot of myos and F's, and so it does get confusing. Fascule is all those muscle fibers put together, makes one fascule. And then you take a bunch of fascules, put them together, makes one muscle. If it wasn't confusing enough. Okay, so this is going down and looking at one myofibril. Remember, we take a bunch of myofibrils, put them together, and make one muscle cell or muscle fiber. So this is one myofibril. This myofibril has the thick and thin filaments, and this is where your actual contraction is taking place, is in a myofibril. Your thin and thick filaments, you have several of them together, and they don't actually touch. They do sit like this in a lattice work. And this one unit of those two things is called a sarcomere. If you didn't have enough S words to, sarcolemma, and so now and sarcoplasmic reticulum and sarcoplasm, and now you have a sarcomere, which is a unit of these things. You do have to know all those words and know what they are. A sarcomere are thick and thin filaments. This is where our contraction is actually taking place. And what is happening, I think I'll talk about it here. Let me look at my next slide before I do it. Yeah. What is happening is we get an impulse. So on this slide, we get an impulse coming down a motor neuron. So this is from the nervous system, and it stimulates this muscle cell, which then travels down inside the muscle cell. Remember, we've got a bunch of myofibrils, and it will stimulate one myofibril. And it all starts with calcium. The actual contraction will start with an electrical impulse. That's what causes a contraction. For me to close my hand and contract my arm and my muscles in my hand, it's an impulse from my brain traveling down the spinal cord to that muscle. So here at this level, what happens is, do I have a good slide? Tell me I do. Because this is very confusing and hard for most people to get, and I don't have a good slide. Okay. So, you got good pictures in your book though, but I'll draw some on the board. So, what you have is, you have two other things, terms you're going to have to learn. And you have what is called troponin. It's a protein. You have troponin, these little beads of troponin, and this is in your book. On page 133, there's a good picture of it. On my board, come on. There we go. And you have troponin. So troponin is sitting on the top of these little loops, and there's some more down here that come down. And they're sitting on tropomyosin, which is this little band coming through here. This is again right here. So you'll have just like that. And so you'll have troponin sitting up here. Why that is important is because myosin, with those little heads that are sticking up, they kind of look like golf club heads. What they do is, because these two filaments are not touching, myosin will reach up and it will grab onto the actin and it will pull it. Release and grab it again, pull it. Get it in my camera. So it'll grab the actin, it'll pull it, grab the next one, pull it, and as it's doing it, this is shortening. So it's grabbing and pulling and pulling and pulling, and it's starting to shorten this myofibril. If a bunch of those myofibrils shorten, the muscle cell shortens. If the muscle cell shortens, then the actual muscle will shorten. So that's what's causing a contraction. Well, this myosin cannot touch or grab a hold of the actin because troponin here is in the way. So these little heads are in the way and it can't grab. So we need calcium. So calcium will come in here and, oh my board. Calcium will come in here and it will bind to those heads. And when it does, it pulls the troponin down. So then it'll look like this. Troponin's there. It's bound to calcium, which in the book they made like triangles. So now those heads are exposed and they can grab a hold of the actin and pull it and pull it and pull it until they get shorter and shorter. And you have a contraction. So calcium is extremely important. We'll talk about calcium a little more in a minute. Yeah, that's it on that one. That's the most confusing part of that. Now to make things even better and harder to understand, like I said, I'll post some videos of this stuff because it is complicated. Your impulse that comes down your motor neuron, inside this motor neuron you have what are called vesicles. Remember we talked about vesicles back when we had cells, and inside there were vesicles. And they could come to the surface and they could let things out. So here, which is exocytosis. So here you have these vesicles. Once the stimulus comes down and causes these to move, they'll migrate to the surface of that. Let me back up. Let me tell you what this actually is. So this motor neuron and your muscle cell, all this together is called a neuromuscular junction. Neuro meaning nervous system, muscle meaning muscle, junction, the two places that they come and communicate.